Hello class, today is the 24th of May, and what we are going to do today is we're going to finish going over that lesson 1 from our new module. As remember, I had left you off with exercise 4 to work on independently, and I said, hey, we're going to go over this. So what we're going to do is I'm going to give away what the answers that we should have gotten for exercise 4 would be. Now, we shouldn't really have had too much difficulty because we kind of came up with the exact formula of how these would be solved in the last one. In fact, we kind of have our general rule that we'll get to in a second. But we should hopefully already have these. Again, the only ones that might actually cause any amount of trouble would probably be C, E, and F. But for A, we should have easily been able to get t plus 5, t minus 5. For B, we should have, maybe not as easily, but definitely still gotten 2x plus 3. 2x minus 3. And then for D down here, we should have been able to get 2 plus B, 2 minus B, without much difficulty. Because again, remember, my 25 up here is basically just 5 squared. My 9 here is just 3 squared. And my 4 here is just 2 squared. Part C here might have caused a little bit of difficulty because we had 2 different sets with 2 different numbers. But in all honesty, C should have been pretty simple for us. We had 4h plus 6k and then 4h minus 6k. Because 16 goes to 4 and h squared goes to h, so that's 4h squared. The 36 goes to 6 and the k squared goes to k, so that's k. It's a horrible k, but it's a k nonetheless. 6k squared. Part E might have given us a little bit of a problem because instead of having something squared, we have something to the 4th power. But something to keep in mind is that x to the 4th, I could say is x squared times x squared, or x squared squared. So what we can split this into is going to be x squared plus 2 and x squared minus 2. So what we can do is we can take our exponent and split it in half into 2 separate groups of 2. We could do the same down here with the x to the 6th. Instead of splitting it into x squared times x squared, this one would be x cubed times x cubed. Because x cubed means I have 3 x's being multiplied. X cubed means I have 3 x's being multiplied. That means I have a total of 6 x's being multiplied with each other. So then this can be x cubed plus 5, x cubed minus 5. Now again, the only ones that really should have given us any kind of trouble would be mostly E and F, maybe C. Everything else should have been relatively easy because we did in fact come up with a general rule, even though we didn't really write it down. But the general rule that we came up with was that if I had something squared minus something squared, I would take my first thing plus my second thing and my first thing minus my second thing. So if I have a squared minus b squared, that's going to be a plus b times a minus b. And that'll be true for whenever I have a difference of squares. It's a special rule whenever I have something squared minus something squared. So what you guys are going to do, the first step of what you guys are going to do is you're going to do questions 5 through 7 here. You're going to solve question 5, question 6, and question number 7 on your own. But that's not where this video is going to end. You can pause if you would like to solve these now and then come back when we head over to the next couple of questions. Or you can watch the rest of the video through and then come back and do these. The next thing that we're going to do, and I'm going to not swap slides yet, is going to be something called the square of a binomial. It's going to be where we have a chunk like this, and we just square it. Now, this is something that we're going to be doing pretty often, and it is something that people make mistakes on time and time again, which is why I want to talk about it now. The big mistake that a lot of people are going to make when they see this is they're going to say, oh, that's x plus 2 squared. Okay, so that's just going to be x squared plus 2 squared. So then my final answer is going to be x squared plus 4. What they do is they just take this exponent and put it above the x, and they put it above the 2. Here's the problem. That's not how this one's going to actually work for us. Think about what this square means. Think about what it means to square something. If we are going to square something, what that means for us to do is it means that we are going to take whatever I'm squaring and multiply it by itself. So instead of multiplying x by itself and 2 by itself, I'm going to actually multiply x plus 2 by itself. So let me put a big X over here. This is not the way to do things. This over here is going to be the correct way to do it. Don't just distribute your exponent. You are going to take the entirety of the parentheses, our x plus 2, and multiply it by itself. And once we're at this step, it's going to be the same steps as what we had done before, where we are going to use a double distributive property, or if you need to use a table for aid still, that's also fine. Personally, I like using the double distributive property. So we're going to take this x is going to be multiplied by the x and by the 2, and then this 2 is going to be multiplied by the x and also by the 2. So what we're going to have is x times x is x squared. X times 2 is 2x. 2 times x is another 2x. And then 2 times 2 is going to be 4. Which means that we would have, in this case, x squared plus 4x plus 4. Is going to be shown off on this slide, except instead of using the x plus 2, they used x plus 3 in order to show this off. So they have x plus 3 times x plus 3, and they get x squared plus 3x plus 3x plus 9, or x squared plus 6x plus 9. What it is going to want us to do, however, now that we know that that's what we're going to have to do, it wants us to make a general rule so that, well, we don't have to do all of the work every single time. If we can memorize our rule, then we won't have a problem. So it asks us to memorize our rules by using these a's and our b's. Okay. So for a, we have a plus b squared. Okay. Well, we know that a plus b squared is going to be a plus b times a plus b. Okay, let's go about doing this. Once again, I'm going to use my double distributive. My a is going to be multiplied by my a and my b. And then my b is going to be multiplied by my a and my b. So a times a is going to be a squared. B times a is going to be, well, a times b is going to be ab, plus b times a would be ba, but I'm going to write it as ab, just because we already have an ab sitting there. And then b times b is going to be b squared. So what I get is a squared plus ab plus ab. Well, I have two sets of ab, 2ab plus b squared. Now, what does this mean? Why is this important? Well, let's sort of take what we have here and let's compare it to what we had up here. I had x plus 3, x plus 3. And I wound up with x squared plus 6x plus 9. Okay? So my x is my a in this case. My x is going to be squared here. Okay, that looks good. Plus 2 times a times b. Okay, so this would be 2 times x, because x is my a in this case. And 3 is my b, so that's 2 times x times 3. Oh, well, the 2 times the 3 does give me 6, and then my x sticks around. Okay, so that looks like that worked. I'll put a check mark here saying, yeah, that fits with my rule. Yeah, that fits with my rule. And then 9, well, it's saying that that's going to be b squared. 3 squared. Oh, 3 squared is 9. That's a good check mark right there. Okay. That looks like this right here looks like a good general rule. At least when we're adding inside of our parentheses. Let's see if anything might change when we're subtracting inside of our parentheses. A minus b squared means a minus b times a minus b. Once again, same as before, we're going to use our double distributive. So my a times my a times this minus b, my minus b times my a, and my minus b times this minus b over here. A times a, well, that still gives us a squared. A times this minus b, or this negative b, means that we're going to be subtracting ab over here. This negative b times this a means that I'm going to be subtracting ba, or I can just be subtracting ab again. And then negative b times negative b, well, good news, a negative times a negative gives us a positive, so we're back to plus b squared. So the only difference is that if I'm subtracting here, that means that in the end, instead of plus 2ab, I'm just going to be doing minus 2ab. But my a squared and my b squared are going to stay the same. They're both still going to be positive. So with both of these being positive, hopefully you'd be able to take a look at exercises 8 and 9 and deal with those as well. So again, your work for today is going to be exercises 5 through 7 and 8 through 9. So basically exercises 5 through 9. That is your work that you're going to have to do today. With that, that's all that I really have for you. I hope you guys have a great rest of your day, and I will see you either for a new video tomorrow or with just a new assignment. Have a great day. See you guys tomorrow.